Okay, welcome to the final video in our three-part series on how to do mechanical rigging in 3ds Max. In part 1, we talked about how to do the HI-IK solver for in-plane motion of joints. We talked about using the HD solver for multiple planes of movement in the second video. In the third video, in 3A, we covered the basics of how do you get an argument-based controller to drive these IK animations. And then lastly, we have how do we drive multiple IK animations that are dependent on each other in a chain. In this particular video, we are looking at a dependency chain of IK solvers starting from this end goal for this IK chain, this HI-IK chain here, following these bones down here through the bell crank. So the first series is going to control the push rod and the bell crank, but that bell crank as it rotates is also the end effector for the HD IK solver in the second chain. So we need to make sure that as we do our animations that we are getting the proper effects for the animations and having the end effectors in the right place at the right time with these chain of effects. Now if you remember in part 3A, what we did is we linked this bell crank to our bone that is controlled by the arg-based controller. So what that means is that this bell crank is no longer being moved by the IK chain bone or series of bones. So as we start moving the strut around, we need to make sure that the end effector that is associated with this particular IK chain here, this HD IK chain, is doing the right thing. Now, in part 2, we made sure that this dummy, which is something that we linked as part of the end effector in the HD case, was controlling the movement, and we ended up linking that dummy to the socket. So the socket is what's dragging that end effector around. So if the socket is attached to our part, then it's not going to move as the strut rotates. So we need to make sure that this socket position is not attached to our actual model. We need it to be attached to the IK bone that was controlling the movement. So that's going to drag it around. So just make sure that this is linked into the proper place. So we're going to drag it and attach it to the root bone in the IK, because that's the root bone, was the bone that was originally controlling the bell crank movement. So now that we've attached that point to that bone, as that bone rotates, that point will stay relative to that bone, and the end effector associated with our HD case is going to follow that point around as well. Now another thing that we need to be careful of is alignments for the various arguments and animations. So as we're starting to do the animations, we want to make sure that where we end up is in an appropriate position to align with the rest of the model. So what we're going to end up doing, since we want the animation for arg0 or for arg5 to be at 0, that's its typical value, we're going to start with the strut in the argument value 1 position, which means we're going to rotate it out back to 90 degrees. There's 90. And you can see that the end effector has moved in relationship to the IK root bone and is no longer in place with the bell crank, the socket position on the bell crank. That's okay. What's going to happen is that as we get the animations in the right positions for the argument-based controller number that we need, we'll eventually switch that back to arg5, and then everything in its movement will end up aligning with each other. So here we are. We've got our bones set up, we've got our strut in position, we've got our IK chains set up. We have not got all the bones set up. So we need to set up our bones. So animation, bone tools, create bones. Again, make sure we're building on side fins. We're going to create a bone structure here and then align it. So select our root bone, align it, position only to the root bone. Now we go to bone edit mode and align it with its IK partner, and select the terminator bone and align it with its IK partner. Now again, we need to make sure that the bones that are managing the using the arg-based controller are perfectly aligned with the IK controlled bones. So we need to go through this again, and we're going to select, choose the bone, and this time we're going to change from position to orientation. Select, align, orientation, select, align, orientation. Alright. Now we have our bones in place that are aligned. We can get out of bone edit mode. It's time to link those bones to our structure. So we've got our root bone that gets attached to our strut. Our wheel assembly is now, instead of being linked to the IK bone, we're going to link it to the root bone of the arg-based controller set of bones. And we're going to select our push rod and link it to our second bone in that series. Alright, so what we have now is two sets of bones that are perfectly aligned with each other. Both of them are linked to the strut, and the parts that were linked to the IK bones are no longer linked to the IK bones. So the IK bones don't have anything linked to them at this point. And we do have the parts that were linked to them now linked to the argument-based controller bones. So the next thing we need to do is attach some argument-based controllers to those bones. So we'll select our root bone, go to the Motion tab, pick Rotation, Argument-Based Rotation, add, again, I'm going to pick a random, not used argument number. We'll call this Wheel Assemb Rotation. And select our second bone, and we'll assign it an arg-based rotation. Low push rod rotation. Okay. So now we've got the bones linked to our model. We've got the bones assigned an argument-based controller, and they're aligned. So now we can start going through our animations. We can select, set the controller to be active. We'll turn on auto key. Before we do that, let's get our animation in the right position. So the timeline needs to match where our current position is. So we're starting out with a value of 1. Actually, it should be here, but that's okay. So we'll turn on auto key, and we're going to move our time slider here because that's where we're going to start our rotations. And we're going to set a key, and then we're going to do the same thing for the lower push rod. It's active, set our key. Alright, now let's move our timeline ahead to 60, or backwards I should say, backwards to 60. And now we're going to rotate it into the fuselage 30 degrees, and we can see that the IK bones are moving, the end effector associated with that goal, with the root bone, has moved with it. So we now need to realign our controller-based bones. So we'll choose this, the root bone on the arg-based controller set, align it in orientation, choose the next bone, and align it in orientation. Alright, it's now aligned with the IK solution that we have in place. Let's move the timeline another 30. And we'll select our strut, rotate it another 30 degrees. And we're going to do the same thing over again. Select our arg-based controller bone, align it with the root IK bone, its partner, select the next bone, align it with the IK partner, orientation. And then lastly, we'll move it to the 0 timeline, rotate fully into the fuselage another 30 degrees, and let's get our arg-based controller bones aligned. Alright, and there you have it. we now have our bones, our arc-based controller bones, aligned with our IK bones over a timeline. And we can go out of auto key, and now we have to go do our fix up. So we're going to select our root bone again, and we'll change the argument number to 5. We're going to select the next bone, change its argument number to 5. And what we should have is an argument that allows our bones to transition. And we can see that as the bones transition, so do the parts that are bound to them. That's our argument-based bones that are moving. Now you can see that the IK bones got left behind. That's because we're not rotating the parts that control the IK. We're using the arc-based controller. So if we actually select this and rotate it, we can see that the IK goes with it. So that's what's happening right now. And we should be able to export this now. Now, more than likely, if we try and export it, we're going to see an error. And let's go ahead and try it and see what happens. So export. And we'll select the EDM model exporter that DCS World wants. Export it to our temporary file and replace it. And yes, we see this optimization error. Now what's happening here is when we unlinked the parts from the original IK bone chain and linked them to the arc-based controller bone chain, the IK bone chain ended up with no parts linked to it. So what we're seeing here is a plug-in error that noticed that we have some bones with no parts attached to it. So what we need to do is just create a dummy. Let's go to our top view. And we want to create a dummy and associate it with our bones somewhere. So let's select, and I'm just going to create a dummy right here, and then I'm going to align it with our IK bone, but I'm only going to do it in the Z, just so it gets kind of overlaying the IK bone chain somewhere. And then I'm going to link that dummy to the IK bone chain somewhere. So now that I have some part linked to the IK bone chain, I should be able to export. And we're going to go ahead and move this into a weight off wheels position, because it should export this time. Alright, so that's basically what it's going to look like when it retracts into the fuselage. And if we export it now, we see that it should export fine, and we'll get our model up and we'll try and exercise argument 5 and see what it does. Alright, here we go. We can see that our aircraft has the wheels rotated into the fuselage in a somewhat compact form, and If we set up argument 5 and exercise it, we can see that it is actually causing the appropriate parts to rotate into position. And there you go. We have our wheels doing the appropriate animation based on IK, being driven by an argument-based controller, and there you go. Thank you for watching.